All right, this is lecture 3 in week 4 on scientific realism and anti-realism. You should have watched and read uh, the stuff on logical empiricism and then on the no miracles argument for scientific realism. Those are both in the Staley book. And now we're moving on to Larry Laudan's article on the pessimistic meta-induction. So Laudan's argument is actually, it's not going to be an anti-realist argument. What he's really trying to do is undermine the argument for realism by Putnam by going through it in sort of excruciating detail. And it's one of the longer articles, not the most difficult one we read, but somewhere in the middle, towards the more difficult side. So this will be a slightly longer lecture than usual, not too long, probably no more than 40 minutes. But I do want to help you through that article. And so I'm going to go through it in almost as much detail as Laudan does, and so that you can make sense of it, because I don't want to leave you hanging out there reading articles that you can't make any sense of. And it's a very important one in philosophy of science. Okay, so Laudan's pessimistic meta-induction. He starts out by pointing out that the no miracles argument is an argument for scientific realism, and importantly, it's an empirical argument for scientific realism. And this is new, this is interesting, right? So it's using evidence in the form of the success of science to make an inductive argument for realism, just as in many of the sciences, right, we use induction for our particular theory of physics or whatever. For a moment, forget about Hume and his arguments, right? It just happens to be the case that we do use induction, right? And we definitely do seem to use it in science as well. So Laudan thinks this is sort of a bold strategy, right? It's good because it means it can be falsified, right? And if you are a logical empiricist, or if you're Popper, you like claims that can be falsified. That means that they are concrete. They refer to something. It's not just metaphysics. Okay, so he's interested in this form of argument. Unfortunately, he thinks it's not going to work, right? So, and to make the strongest sort of argument possible, he is going to give you the most plausible version of scientific realism, which he calls convergent epistemological realism, right? We'll call it CER. So CER is just this claim that all these scientific successes, landing people on the moon, curing diseases, and so on, all this is evidence that our successive theories are getting closer to the truth. So the epistemological part is, right, that success gives us reason to believe in the truth of science, rather. And the convergent part is that our theories are getting better and better, right? They're getting more true, they're getting closer to the true, because any scientific realist has to admit that we replace old theories with better theories, right? But that's not a big problem if you think it's just the continuous improvement, right? Rather than a wholesale rejection, right? Saying, oh, everything we did before was bad, and now we finally have it right. So Laudan sort of splits CER into sort of several fundamental claims. So here they are. The first one is a claim that scientific theories, at least in the mature sciences, right? So again, he's cutting his opponent some slack, and he's saying, okay, like, I'm not asking you to defend the caloric theory of heat, right? Where heat is caused by the substance called caloric, right? We can just restrict to the mature sciences, whatever that means, and that's, we'll see, sort of a tricky definition, right? But he's cutting his opponent some slack. Those are typically going to be approximately true. Again, cutting his opponent some slack. Look, I get it. You're only claiming approximate truth. Maybe it'll be improved, right? Maybe we'll get another theory later that'll be even better. But you are claiming, at least, Mr. Realist, right, that mature scientific theories are approximately true, and that the recent theories, this is the convergent part, are even closer to the truth than the older ones. So that's R1. R2 is sort of a mirror reflection of R1, and it frames it in terms of reference. So we talked about truth a bit, and we talked about Swartz in his account of regularity theories of laws of nature, and just the basic idea is that a sentence or a theory, right, a sentence in a theory is true just in case it describes the world as it is, right? And so for that to be the case, the words in your theories have to pick out actual things in the world, right? So for a sentence like "my cat is black" to be true, I better have a cat, right? If I don't actually have a cat, then I've just said something false, right? My words don't pick out something in the real world. So if you're a realist, then you do want to claim that the words in your theories, even the kind of the trippy ones like electron, sea of negative energy, stuff like that, actually does correspond to something in the real world. A couple more of these claims. Now, these claims are the ones that sort of cover the convergence part of convergent epistemological realism. Um, so you want to say that successive theories in any mature science will preserve the theoretical relations and the apparent reference of the theories before them. And R4, they should explain why the previous theory was successful insofar as it was. Presumably, the new theory will be more successful, but this is convergent and not just wholesale rejection of old theories, then the new one should explain what was good about the old one. And the classic example of this that is pointed to by realists is classical mechanics, right, as posited by Newton, and then the improvement on that by Einstein with relativistic mechanics. So I believe we discussed that once upon a time, right, Newton's theory of just the way the bodies move in the world, right, gravity and mass and acceleration and the relation of all of these properties was so successful that there was a long period of time where people just thought we nailed it, right? We got the theory of the universe, the basic physics of the universe. And then eventually, early 20th century, Einstein comes along and has to actually make some radical revisions because of some certain kinds of observations we make. He says, you know what, actually, I think we have to say that mass increases as you go faster, right? Mass is not just sort of, mass is relative to your speed, your velocity. Um, and also time is going to dilate, right, relative to your velocity. And there's going to be a single thing called space-time that can actually be distorted by objects with large masses, right? So very different understanding of these terms, mass, right, and time, space, and things like that. And you might think so different that we just have to scrap Newtonian physics. But what realists will say is, no, Newtonian mechanics is still true, but within sort of a more narrow realm of objects that aren't moving super fast and objects that aren't super big compared to, like, the Earth or the sun, something like that. So, tables and chairs, rocks, these are perfectly adequately described by the laws of classical mechanics, right? So we have an idea, this is a limiting case, right? So classical mechanics is a limiting case of relativistic mechanics, given certain assumptions, right? Confined to a certain area, it's perfectly good. And then we can explain why those theories were so successful, right? Even though we know we now have a better one. So this is the idea of the convergent part, R3 and R4. Okay, so if we have those four claims, now we need a fifth one, right, that sort of makes the argument. So that's our evidence. And then R5 says, if you have R1 through R4, right, that's going to entail that our mature scientific theories should be successful, right? Indeed, these theses constitute the best, if not the only, explanation for the success of science. So the IBE is something like this. Premise 1, our mature scientific theories are successful. Premise 2, the best explanation of the success of our mature scientific theories is that they are true and their central terms refer. 3, therefore, our mature scientific theories are true and their central terms refer. Now, remember I said that inference to the best explanation looks a lot like a deductive fallacy, right? A bad sort of deductive argument called affirming the consequent. It goes something like this. Hold on. Pardon me. P, if P then Q, Q therefore P, right? So as a deductive argument, that's terrible. But as an inductive argument, as argument inference to the best explanation, it can work. And I bring that up because Laudan is going to talk about that conditional a lot, right? So again, just like if Nate is the murderer, then his DNA will be at the scene. He's going to be talking, right, about a conditional, and he's going to be questioning the truth of it. But something like, if scientific theories are true, then they will be successful, right? If the terms in the scientific theory refer, then they will be successful. So this is a crucial premise in this IBE for scientific realism, and Laudan's going to question that conditional. So you can do sort of two versions of the argument, one with this conditional about truth, and the other with the conditional about reference, right? You could say, so here we have both sort of packed into a single argument. So we have premise one here, if scientific theories are true, then they will be successful. The second premise, if the terms in the scientific theories refer, right? So if electrons actually exist, those theories will probably be successful. Three, right, we have sort of the datum that in fact our theories are successful. So we can conclude, right, inductively that the best explanation by IBE, our theories are true and their terms refer. But Laudan's going to attack those two conditionals sort of separately. And let's talk about the convergence part of it, right? So here's the argument for convergence. The idea is if our theories are gradually getting better and our old theories were totally wrong. So premise one, if the earlier theories in a mature science are approximately true, and if the central terms of those theories generally refer, then later more successful theories in the same science will preserve the earlier theories as limiting cases, right? As relativity theory preserved classical mechanics as a limiting case. Premise two, scientists do in fact seek to preserve earlier theories as limiting cases, and they generally succeed. Therefore, right, the best explanation is that earlier theories in a mature science are approximately true and they genuinely refer, right? So this is an argument to the effect that our older theories aren't total crap, right? We're getting better. We're improving them, refining them. Okay, so Laudan's going to pick apart these arguments. He's going to say that almost all of these premises are false. The only thing he will agree with is that our theories are successful. But all the other things about reference entailing success or truth entailing success, he's going to pick those apart. So let's just start with reference. Again, what we mean by reference and what we mean by saying that a term refers is just that the thing it represents actually exists. So the word cats has a referent, it's cats. So the question we want to ask is there a referent of the word electron? Or, importantly, in some of our earlier theories, was there a referent of things like phlogiston or caloric, right? Remember, caloric was supposed to be the substance that was responsible for heat. Phlogiston was supposedly a substance that was responsible for fire. Right? Do those things actually exist? Right? And if they do refer, does that explain the success of science? Right? Okay, let's let Laudan go to town on these claims here. So he says this part, right, actually seems to rely on some other claims, right? So those claims are these. First, the theories in our advanced or mature sciences are successful. We're probably going to grant those. But we have another claim. A theory whose central terms refer will be a successful theory, right? Then if a theory is successful, we can infer that its terms refer, right? So this is the IBE. We think that's the best explanation. And all the central terms in the theories in the mature sciences do in fact refer. Right? So he thinks maybe S1 is true, but all the rest of these are going to be false. And if so, then the inference to best explanation from reference is going to be no good. So first, maybe we should talk a little bit about what it means for theory to be successful, right? So we sort of talked in general terms. Oh, we landed man on the moon, right? Therefore, right, science is successful. But we should be a little bit, we should try to be a little bit better about our description of what success means. So it seems that the realist, what they mean by success means something like makes correct predictions, right? Or maybe allows us to manipulate things in the world. Um, and if they want to be convergent realists, right, and say our old theories weren't total crap, then they need a definition of success that also applies to those old theories as well. And so if you, that would make sense then to say that success means correct predictions, right? Old theories did make correct predictions. That's why people kept them around as long as they did. Um, so, and they did allow us to manipulate some stuff too. So if I have a caloric theory of heat, right, I'm still going to predict that if I put a kettle full of water on a flame, that the caloric will flow from the flame to the through the kettle to the water. It will heat up the water and it'll boil, right? So the caloric theory makes a perfectly good prediction. It allows me to make tea. It allows me to manipulate the world. So by that measure of success, then the older theories were perfectly successful. But here's where Laudan comes in and says, I don't think that conditional is true, right? Just because the terms in your theories refer, I don't think they're going to be successful. I don't think they're going to make good predictions. He says chemical atomic theory in the 1700s was a disaster, right? So they had all the right elements, right? But the way they thought that they were like related to each other was totally wrong. So they thought that all the heavier elements were made of hydrogen atoms, right? Now hydrogen atoms exist, but they don't actually sort of all compile or combine together to make like lead, right? That's not how lead is composed. We had an early theory of water that said it was just HO instead of H2O. Now again, hydrogen exists, hydrogen atoms exist, oxygen atoms exist, so we think even now, but they certainly were not combined in that way, right? And you get very wrong, very bad predictions from these early theories. So long story short, it's not enough for a theory's terms to actually refer to something for it to be successful, right? So that conditional, if the terms refer, then it's successful, not a true conditional, right? So that part is false, and that's a crucial premise in the argument for realism, at least apart from reference. What you need, in addition to picking out the right things with your reference, is also to describe their relations in the right way. You might think about it the other way, right? So does the success of a theory entail that its terms refer? To make this inference any good, it needs to be the case that the successful theory has referring central terms, at least most of the time, right? So there's a lot of successful theories out there that actually didn't have terms that referred. We've talked about caloric theory of heat, right? We've talked about phlogiston. There's many more. We thought that electricity was like a fluid at one point. So those are all successful theories. They actually made good predictions, right? But their terms didn't refer. So Laudan not only sort of picks apart the important sort of conditional for the IBE, which is if it refers, then it'll be successful. He says also the other way around is bad too, right? You can be if successful, it doesn't mean that your terms refer. So this relationship, right, between having theoretical terms that refer and success is just not, there isn't any relation really, right? So this, either way you look at it, it's conditional, it's not going to be true. Okay, having picked apart the one version of the IBE, let's look at the truth version, right? So the idea is if a theory is approximately true, then it will be explanatorily successful. Or maybe look at the other one, right? That first one is really the main one for the IBE, but he says we'll look at it the other way around too. And I think either way it's bad. You might say if a theory is successful, then that gives us reasons to think it's true. And again, we're just talking about approximate truth, right? Actual truth is tough, right? We all kind of assume that probably down the road our theories will be improved by later theories. Okay, but this is a problem though, right? If you weaken your claim to approximate truth, right, like a really true theory probably would be successful, right? Sure. But the problem here is they don't want to commit to actual truth, right? Because they know that, first of all, for the convergence part, they know that the old theory wasn't like actually true because it's since been improved. And then looking to the future, probably um, our current theories will then be improved again, and they won't be strictly speaking true. So the realists can only really talk about approximate truth, but that conditional between if your theory is approximately true, then it will be successful, much less obvious that that's true than the conditional that if your theory is big T true, it'll be successful. Um, to even make sense of that, we have to sort of think about what could it even mean to be approximately true. Um, so one thing you might think is that if a theory is approximately true, we mean that it's mostly true. But that doesn't cut it because a mostly true theory will give you lots of false predictions. They can even give you mostly false predictions, right? Because depending on which parts are true and which parts aren't, um, right? One little sort of like false premise in there will give you a lot of false predictions. So then T1, right? This conditional, if your theory is approximately true, then it'll be successful. Laudan says it's not obvious to me that's true at all, right? Even if it's a little bit false, it's not going to be very successful. Well, what about the sort of other version of the conditional? Um, if the theory is successful, does that give us any reason to think that the theory is at least approximately true? Um, well, no. I mean, for example, right? No theory is even going to be approximately true if its central terms don't refer. And we have a long, long history of successful theories whose central terms don't refer. So again, we moved away from the reference part to the truth part, but this becomes relevant to the truth argument because it's saying your theory can't be true if the terms don't refer. And look at these. Ptolemaic astronomy, right? So here is a successful theory for a while, right? You could definitely make predictions about the positions of the stars and the planets and stuff like that. But look, it's got Earth, right? Smack dab in the middle. And it's got these crystalline spheres, right? That that all of the successive planets exist in, right? It's just we know now, obviously, because we've flown off of the Earth, we know none of this is true, and many of the terms in this version of astronomy don't refer. There are no crystalline spheres. The humoral theory of medicine, right? So this was we talked about this in a previous lecture. This is the claim that like disease is a result of your various humors being out of balance. So, right, your blood and your black bile and your yellow bile and your phlegm were out of whack. Uh, the caloric theory of heat we've discussed a lot. This here is some Americans, some good old Revolutionary era Americans proving the caloric theory of heat is false because you can create heat just by sort of hollowing out the barrel of a cannon, right? So you had a cold thing just moving real fast, and somehow heat gets created, so it wasn't like flowing from a hot thing to a cold thing. You got phlogiston theory of chemistry. Here's a picture of the apparatus that was used to prove that false, but I won't get into the details. So and so on. There's no phlogiston, there's no caloric, right? There's no humors, there's no crystalline spheres of Ptolemaic astronomy. But they were all very successful theories, right? They made good predictions. So again, this link between success and truth is broken, right? Because via reference, right? So it can't be true if the terms don't refer, um, and yet these were false theories that were successful. Okay, and so on and on. And the issue is, though, these aren't just historical oddities, right? That don't have much to do with modern science. We've seen a continuity between the equations that describe the behavior of light as waves in the ether and light as electromagnetic waves. So the predictions were still successful, right? Whether you think that light is a movement in some ether that we now know doesn't exist, or if we think it's electromagnetic waves, there's still success either way, right? They make the right predictions. So there's not this connection between success and being true or referring to actual things that exist. And now he wants to go after this idea that, right, the new theories somehow retain parts of the old theory. And Laudan says, look, you realists have really been beating this sort of dead horse of classical mechanics to relativistic mechanics a lot. But that's kind of your only example, right? There's most of the time, actually, what happens is the old theory just gets scrapped. So, and here's a sort of a long quote to make that point. Copernican astronomy didn't retain all the key mechanisms of Ptolemaic astronomy. Newton's physics didn't retain all or even most of the theoretical laws of Cartesian mechanics. Franklin's electrical theory didn't contain its predecessor as a limiting case. Relativistic physics got rid of the ether, right? Statistical mechanics, they don't keep thermodynamics around. On and on and on, right? So he says, okay, maybe you have, in some sense, right, relativistic uh, physics sort of kept part of Newtonian physics as a limiting case, but more often than not, the new theory just gets rid of like a lot of the main posits of the old theory. Okay, and now we want to talk about inference, the best explanation, just in general. Is this even this form of argument that that Putnam uses implicitly? Is this even a good way to argue for this sort of thing? Now, of course, we've seen technically it's affirming the consequent, but that's fine, right? A lot of people describe science as proceeding by IBE, right? Your theory is the best explanation of the data. Um, but Laudan wants to deny this, actually. He says, um, no, he doesn't think it's IBE. So you can always create some conditional um, whose consequent is true, just sort of ad hoc, right? But that just doesn't give us any reason to believe it. So I can, in other words, I can always come up with a theory. I can always explain the data in some way, right? But it's going to be when it's ad hoc, we say that it's just sort of like at the moment we just sort of pack in some extra theorems that predict stuff, right, that we already know is true. So I can always make up a theory that makes the right predictions, right, if I already know what I'm trying to predict, right? But that's not the point. And sort of one example of this was in Ptolemaic astronomy, right? They kept trying to save it, even though the data was like not matching up with the theory by adding all these extra little motions, these little what they call epicycles that the planets were doing. They say, oh, okay, well actually the stars they move. Not only do they and the planets they not only move like around the sun or around the Earth in this one way, but they also do little extra little movements or whatever. Yeah, you can keep packing on complicated little extra things to your theory to make it match the data. Um, but that's just bad, right? What you really want is a simple theory that makes a bold prediction of something that we've never observed before, and then we check it out, and lo and behold, it works out, right? Um, and what Laudan wants to say is what scientific realism is doing is just some ad hoc stuff, right? They've got the data, and they're just sort of like cobbling together a theory that predicts the data, but it's sort of after the fact, right? They're not making a bold prediction. Right? Make a big bold prediction that may well be false and then see if it's false. Don't just sort of make up a theory to match the data. And that's what he thinks that the realists are doing with this IBE.